Hey, stat students. Just wanted to give you a little bit of a primer about the probability unit that you're going to start because probability is super, super relevant right now. So here's what I mean. The first thing that I want to show you is there exists a coronavirus calculator which calculates your risk of dying from coronavirus. And it takes into account these different conditions. So let's check it out. All right. So let's see. I am 30. I have no pre-existing conditions. My social contact is probably small. My hygiene is probably average. My gender is female. Health services are good. And my climate is cold. These two, the population IR is estimated from the current reportings about the virus, and IFR, the infection fatality rate, is also an estimate at about 1%. So this tells me I have a 1 in 25,720 chance of dying from the coronavirus. So that seems like I'm probably going to be okay. But let's look at some other probabilities that are associated with the virus and the news right now. So here we're saying that Italians think that dodging the coronavirus is strictly chance. It's all about probabilities and randomness. Here we are looking at how the probabilities change when ventilators are small. Here they're citing a 3% chance of someone attending a 1,000 person event. There's a 3% chance that someone at that event has the virus. Here it's just talking about what is the chance of dying. So lots of statisticians and probabilists are out there right now trying to answer some of these questions. Looking at the risk assessment is the job of a mathematician. Even looking at the economy, like what is the chance that we're going to go into recession? How is this 80% calculated? And I just wanted to show you the graph over time. This is where we are now in the probability that a recession will occur. Here is an article about the death rate. So the death rate, in a sense, is a probability. This is the probability of dying from the coronavirus. And notice that the numbers are ranging by quite a bit. Again, a question of probability. So you might have a 50-50% chance of being infected if 10 viral particles get in your eye. But if you put 1,000 particles in your eye, what's going to happen? All of these numbers are playing into probabilities that are calculated. Finally, there's this thing called probability neglect, and it's about the way that we interpret probabilities that we see in the news. So let's basically talk about how some of these are calculated. So this is the most basic way to think about the death rate. The number of deaths due to coronavirus divided by the number of cases. This is the probability of dying if you are infected with the virus. It does not represent the probability of dying in general. So you can see how those range for elderly people down to young people. They also calculate the difference between male and female. So how would this probability estimate, this death rate, change? If we're getting different numbers, we can't be plugging in the same number of deaths and the same number of cases. So for males, this is the number of males who died divided by the number of male cases. And then for females, the number of females who died divided by the number of female cases. And similarly, they did this calculation looking at, of the confirmed cases, how many of those died and had a cardiovascular disease. So breaking it up into these little categories. And that's kind of what that original calculator was doing too. But we're definitely missing something here. It can't just be simple number of deaths divided by number of cases. And we kind of hinted at it. This is you have the disease and you've been confirmed and you die. So there is a notion in probability called conditional probability. And this is what the media needs to get better at reporting. So the way that a conditional probability works is, think of coronavirus. You have a pre-existing condition, your chance of dying is going to go up. So you're going to learn this formula called Bayes' theorem, which basically says that the denominator is going to end up being a smaller value. Like, we're only looking at the population of people who are over 65 and have a disease. So here they work out an example of the probability of dying from COVID given that you're under the age of 65. So what this formula says is you want to look at the probability of being under 65 given that you died from the disease times the probability of having dying from the disease in general, divided by the probability of being under 65. This is a smaller population. And so we end up with a probability of actually 90, where is it? 0.7% is the final result. So your chance of dying if you're under 65 is actually quite small. If this were over 65, you would end up with something a lot bigger here. So the last thing that I want to talk briefly about is when we make these calculations, we're using imperfect data. We're not actually getting the true probability of dying from the coronavirus. There's always uncertainty. So each bar here represents a different statistician and the estimate that they came up with for the number of total cases. However, the length of the bar represents how certain they are. So this particular mathematician was really uncertain. But when you put all of their estimates together, you can see, so here this is basically saying that about 8 of the people that they asked to make an estimate guessed that the number of cases is going to be between 0 and, 100. But here, we're saying that the majority of people that they asked think that the number of cases reported is going to be between 10,000 and 20,000. So that's probably the number of cases that will be reported. Again, we have lots of uncertainty when it comes to the accuracy of the reports, the estimated death toll. But if we want to look at the true death toll, we ask all of the experts to make their estimate, and we look at the value that had the most estimates. So this idea is how you can calculate a true probability by using a bunch of experimental probabilities. So I hope that this gives you kind of a broad overview of where probability is going to come in your daily life and how it's extremely relevant right now. And I hope that this unit also gives you a way of interpreting those probabilities that you hear in the news in a more informed way.